Ever get that feeling that your Python code is, well, just a bit sluttish? It turns out there's a built-in tool, one that a lot of people overlook, that can give you a massive speed boost. It's called a set. And today, we're going to pull back the curtain and see exactly how it works its magic. Okay, think about it like this. You need to find someone's number in a huge old-school phone book. Are you going to start at the letter A and flip through every single page, or would you rather use a magic directory that instantly tells you, hey, the name you want is on page 734? The choice is obvious, right? Well, that simple idea is the key to understanding just how powerful Python sets really are. And that's pretty much the difference between searching in a Python list versus a Python set. A list is that phone book. You got to scan it, one item at a time. A set, that's our magic directory. You get an answer almost instantly. So how in the world does it pull off this trick? Now, we're not talking about a small improvement here. This isn't just a minor tune-up. It's a fundamental difference in how they're designed. So let's get into it and uncover the engineering that makes all this speed possible. First things first, what even is a set? Well, it's just a collection of items, but with two very important rules. One, every single element must be unique, no duplicates allowed. And two, it's totally unordered. A set doesn't care if you added apple before banana. This very specific structure is what gives it its superpowers. So, what's the secret sauce? What's the set's secret weapon? Let's pop the hood and see exactly how these things are built for pure, unadulterated speed. The magic all comes down to a data structure called a hash table. Now, I know that sounds a little technical, but stick with me. Don't think of it like a simple list. It's more like a super organized filing cabinet that's designed for one thing and one thing only, getting you what you need right away. At its core, a hash table is a really smart system that can just jump straight to where an item is supposed to be. It doesn't need to waste time checking all the other elements to find what it's looking for. This is how we go from that slow page-by-page scan to just instantly flipping to the right one. So how does this jumping actually happen? It's a brilliant process called hashing. Let's say you add the number 30 to a set. Python takes that number and runs it through a special hash function. This function instantly spits out a unique code, kind of like a serial number. And that code isn't just a random number. It's the element's direct address inside the hash table. It tells Python exactly where to put it and, more importantly, where to find it later. Okay, so we've been throwing around words like fast and instant, but in computer science, there's a much more precise way to talk about performance. It's called time complexity, and it's the language we use to measure just how efficient our code really is. First up, we have the holy grail of performance, O1, which we call constant time. This means an operation takes pretty much the same amount of time, whether your collection has 10 items or 10 million items. It doesn't matter how big it gets. The lookup is almost instant. And that, my friends, is the magic of sets. And on the other side of the coin, you've got O of n, or linear time. This is where the time it takes grows in a straight line with the number of items in your collection. That's the n. So if your list doubles in size, finding something in it will take roughly, you guessed it, twice as long. This is our phone book scan. The more pages, the longer it takes. So, okay, we have these abstract ideas, O of 1 and O of n. But what does that performance gap really look like when the rubber meets the road? Let's visualize it. And wow, just look at that. The bar for the set lookup, our O of 1 operation, is so tiny you can barely even see it. It's flat. But the list lookup, as the data grows, the time it takes just skyrockets. The difference isn't just big, it's astronomical. When it comes to finding things fast, sets are playing a completely different sport. All right, it's time for the showdown. Let's put lists and sets in the ring, head-to-head, and see how they stack up across the most common things we do with them. Check this out. For searching, adding, and removing items, sets are O of 1. Constant time, blazingly fast, every single time. Lists, though? They're a mixed bag. Sure, adding something to the very end is quick, but searching for an item or removing one from the middle? That forces that slow, painful O of n scan of the entire list. For these key jobs, the set is the clear winner. No contest. But here's the catch. There's always a catch, right? To get this incredible speed, sets have to give something up, and that something is order. Because items are stored based on their hash code, not when you added them, there's no concept of a first or last element. You can't ask a set, hey, give me the item at index 0, because indexes simply don't exist. And this is a really important distinction to make. Checking for one specific item in a set is super fast. But if you need to loop through and look at every single element one by one, well, you still have to visit every single element. That operation is still O of n, because the time it takes is always going to depend on the total number of items you have. So, knowing all of this, how do you pick the right tool for your project? That brings us to the big question. When exactly should you reach for a set instead of a list? Here's your simple cheat sheet. Grab a set when you need lightning-fast membership checks, asking, is this item in my collection over and over again? Use it when you absolutely have to make sure every item is unique, because sets handle that for you automatically. And most importantly, use a set when the order of the items just doesn't matter, especially if you're adding and removing things all the time. So if you only remember one thing from all of this, make it this. Sets are your best friend when you need to know if something exists in your collection, and you couldn't care less about where it is. Speed over sequence. That's the set's motto. So there you have it. The secret is out. You now understand the power of hash tables and the incredible speed of O1 lookups. The only question left is, where are you going to use a set to make your code fly?